Hi, my name is Anj, and I work as a software developer and a technical co founder at Happy Plum. Today, we'll be talking about why OpenTelemetry is important for cloud native applications. As we transition to microservices and cloud based architecture, applications are becoming more distributed and interconnected. Each service may run on different servers, interact with various APIs, and generate unique sets of data. This complexity makes it challenging for developers to monitor how these systems work together effectively. Without robust monitoring tools, developers often rely on separate solutions for metric, logs, and tracing, creating silos of information. This lack of integration complicates troubleshooting and hinders performance optimization. OpenTelemetry solves this problem by providing a unified, standardized framework for collecting telemetry data. What does this mean for developers? OpenTelemetry not only centralizes the collection of traces, metrics, and logs, also ensures that captured it in a consistent format regardless of the technologies. It allows you to see exactly how services are performing and quickly diagnose problems with complex workflows. Open telemetry, key unique selling points, USPs. Let's delve deeper into standout features that make open telemetry a must have for observability in distributed systems. Distributed tracing. OpenTelemetry uses spans and traces to map the journey of a request through multiple services. Each span represents a specific unit of work, such as database query or an API call. These spans are automatically created and linked, forming a complete trace. For example, in a Python Flask application, OpenTelemetry can trace how a user request flows from a web server to backend database, highlight delays or error at each stage. This level of granularity helps developers pinpoint issues such as slow database query or a failing API call. Metric collection. Metrics are vital for understanding the overall health and efficiency of a code. OpenTelemetry allows you to collect standard metrics such as request rate, latency, and error counts, as well as define custom metrics tailored to your application. In a Flask app, you can configure OpenTelemetry to monitor the number of requests handled by a specific endpoint or measure response time for critical functions. These metrics can be exported to tools like Grafana for visualization and analysis. Structured log management. OpenTelemetry enriches your application logs by adding trace context such as trace IDs and spam IDs. This contextual information connects each log entry to the corresponding trace, provides a complete picture of what happened during a request. For instance, if a user encounters an error, the trace context in the log can show exactly where the error occurred, which services were involved, and this saves time during debugging of eliminating guesswork. Seamless integration. OpenTelemetry supports integration with popular observability tools including Jaeger for tracing, Splunk for logs. These flexibility ensures that you are not tied to a specific vendor or tied to it, enabling you to build a customized observability stack. For developers, this means you can continue using your preferred tool while leveraging the power of OpenTelemetry for unified data collection. OpenTelemetry, code-wise technical benefits. Let's talk about how OpenTelemetry benefits developers in practice. Distributed tracing. When you can use OpenTelemetry in a Python Flask application, it automatically instruments incoming requests. For each request, OpenTelemetry generates a spam that records details like the request method, URL, and the execution time. These spans are linked together to form a trace that shows the entire request journey. For example, if a request passes through a load balancer, an authentication service, and a database, OpenTelemetry will create spans for each step. These spans include metadata like the duration of database queries and the response time of APIs, making it easy to identify performance bottlenecks. Metric collection. OpenTelemetry metric module allows you to monitor key performance indicators. For instance, in a Flask app, you can define a custom counter metric to track the number of requests to a specific endpoint. This counter increments each time the endpoint is accessed, providing insights into traffic patterns. Additionally, you can measure latency for critical functions by using a histogram metric, which records the distribution of response time. This metric helps developer make data-driven decisions such as optimizing frequent access endpoints or scaling resources during high traffic. Logging. OpenTelemetry enhances your logs by embedding trace context. This means every log entry includes trace ID and spam ID, which links the log to its corresponding trace. For instance, if a user encounters a 500 internal server error, the log will show the associated trace ID. By following the ID, developers can see the full trace, including the spans that contribute to the error. This end to end visibility makes debugging faster and precise. OpenTelemetry in action. Code example. Here is a deeper look at what happens behind the scenes when you integrate OpenTelemetry into a Python Flask application. Tracing. OpenTelemetry sets up a trace provider which manages trace data. Each request generates a spam, recorded details like the start time, end time, error time. The tracer automatically links span together, forming a trace that maps the request journey through the system. Metrics. OpenTelemetry meter provides allows you to define custom metrics. For example, you can create a counter to track the total number of requests or a gauge to monitor memory usage. These metrics are updated in real time and can be exported to monitoring tools for future analysis. Logging. OpenTelemetry uses trace context to enrich logs with additional metadata. This metadata connects logs to specific requests, makes it easier to correlate error with traces and metrics. To integrate OpenTelemetry into your Flask app, you can use the Flask instrumenter library. This library automatically instruments your application, adding tracing and metrics collection to your existing endpoints without requiring major code changes. How to get started contributing to OpenTelemetry? Prerequisites. Before you submit code to OpenTelemetry, you need to have a few things set up. Create a GitHub account before getting started. Sign the CLA, Contributor License Agreement. Read the Code of Conduct, and then you are ready to make a contribution. Conclusion. To wrap up, OpenTelemetry is more than just a tool. It's framework that simplifies observability in complex distributed environment. By unifying the collection of trace, merit, and logs, it provides developers with a comprehensive view of application. The key takeaways: enhance observability. OpenTelemetry gives you end-to-end visibility into your application's behavior, faster debugging. Trace context in logs and spams help you pinpoint issues quickly. Improve performance. Metric data allows you to optimize resource usage and improve response time. Seamless integration. OpenTelemetry works with existing tools, ensuring flexibility and scalability. If you are working with cloud native application, OpenTelemetry is an invaluable asset. It's easy to implement, high customizable, and bring immense value to modern development workflows. Thank you for your attention. I'll be happy to answer any question about OpenTelemetry in the comment section below. Thanks for today.